Another type of problem that's quick and easy to do using triangles are rate of descent problems. So for these kind of problems, these show up on the FAA instrument exam, and you're asked to figure out what rate of descent you have to maintain to stay on a glide slope. Usually the glide slope is given in degrees, which is a perfect setup for a triangle. So in this question, we're told to refer to a specific chart. And I've put the chart up on the screen. It's small and pixelated and hard to read, but the important part is right here under the red circle. The value of the glide slope is a 3-degree glide. So if you want to stay on the slope, then you need to make sure that you're descending at a rate of about 3 degrees. So let's draw that out. You're in an airplane and you want to descend at an angle of 3 degrees relative to the ground. The problem told you that your forward airspeed was 90 knots. So if you're moving forward at 90 knots, how quickly do you have to be descending in order to make that a 3-degree descent? Again, a perfect setup for a very quick and easy triangle problem. In this problem, we're asked to solve for the side that's opposite of our 3-degree angle, and we know the length of the hypotenuse. So opposite, hypotenuse, and angle means sine. So let's look at the sine function. We plug in our angle, we plug in our hypotenuse, we put an x in where the opposite is, solve for x, and we get 4.7 knots. So we have to be descending at a rate of 4.7 knots. Well, knots is nautical miles per hour, and descent rate is usually given in feet per minute. Fortunately, the FAA practice exam, or the FAA exam rather, has a flight computer which allows you to just type in 4.7 nautical miles and convert that into feet. If you do that, you'll get x is a descent rate of 28,557.7 feet per hour. One more step divides that by 60 in order to come up with the feet per minute. So 476 feet per minute is the rate of descent you would need to maintain in order to stay on this glide slope. So let's go back to our question, and we see that option B, 480 feet per minute, is pretty close to what we got. And it's probably close enough to be safe because we can assume, well, we're not going to assume, we're going to see that the FAA just reads their value off of a chart. So how does that chart work? If you were solving this the traditional way without using any trig functions, you would just go to a chart like this, move down along the leftmost column until you find the 3-degree value, and then move across until you reach your ground speed. So for a 3-degree glide at 90 knots, this chart reads 478 feet per minute of descent. And the difference between that and the answer we got can probably just be attributed to the rounding error in converting from nautical miles to feet per minute. In general, if you're given a rate of descent problem and you want to just have a formula memorized in order to solve it quick and easy without looking at a chart, you can do 101.29 times your ground speed times the sine of your descent angle. This will always get you the correct value, or the value that you would have found if you had looked at the chart. But here it's definitely easier to just draw out the triangle and solve it on paper. That way you don't run the risk of not remembering that coefficient correctly.